Well, now in this example we will talk about Petri Nets. So I created a new project and I select this one, weighted Petri Nets. Here you see you have just 4 icons here and nothing more. So let's see what we can do with that. First, if we start with a place, our first place will be active from the beginning on. That's why we have already a token in it. The others will be just empty. And like in graph sets, between 2 places, we always have a transition. Notice in graph sets, we talk about steps, and here we talk about places. It's not quite the same. The reason is, here we talk about tokens. We may have, for example, many tokens in our places. And the way it works is dependent on the number of tokens a place can have. If we do run that now, what happens? So here we have 3 tokens at the beginning. The crossing here consumes 1 token and produces 1 token per default. Now if you say I consume 2 and I produce 1, it happens like this. Of course, you can also double click here again and say, like in graph sets, we wait for 1 second after step 1 was activated and then do the transition. So 1 second after the beginning, 2 tokens were consumed here and 1 was created. Okay, that's the way Petri Nets run. And here you see at glance why they are called weighted Petri Nets, because those arrows have some weights. Okay, let's go on. If we do something like that, and let's say here we just have 2 tokens. If I run that, after 1 second, it went through. Maybe I also want to add a delay. So after step 2, I wait for 1 second. On step 3, or I mean place 2 and place 3, I wait for 1 second also, and we get something like that. Okay. What we can also do is, from a transition, we can use the context menu to add some other stuff. For example, a new place. I get something like this. From a place, I can also add a new place. That means it creates a new transition and a place. From a transition, it creates a place and another transition. So, and you can also do something like insert alternative place up left, you get something like that. Alternative place, up right, you get something like this. And here, well, double click. Here you can add some weights. You can say how many tokens you want to consume from the left, from the middle, and from the right side, and what you want to produce underneath. That means you can give a weight to all your arrows here. Okay, so if I say now from the middle I want to consume 2 tokens, that means I have to have 2 tokens here. So I also have to produce 2 tokens here. And then maybe I also want to create a condition here, a crossing condition, which will be a combination of a condition and E up, which will be the event. And here I will say from step, I have to be careful here, from step 5, I wait for 1 second. So now, after 1 second, I consumed 2 tokens here, I produced 2 tokens there, and now we are ready to cross this one if the condition is true. So the condition will be true if A is on and the E event up comes up. So like now. Okay. I can also add an alternate place below. And now I get something like that. Okay, as soon as the transition is crossable, the places underneath will be served. And they will be served as designed, and meaning here we will produce 1 token, and here on the right side also 1. I can put 2, for example, here. And we will see 2 tokens were produced here now. Now I can go on here, I can say something like this, and alternate transition, select all, I will say from step 8, 1 second later we go here, maybe here I let it just like it as it is, and we see what happens. The fact is, place 8 were deactivated at glance because of this, and so this one could not be served. If I say something like this. Now both can be served. Even though there are alternative places here, as the condition is the same at the moment this one is active and there is enough tokens to serve both were served. Okay? If I say, for example, here I consume 2 tokens. In fact, theoretically, here I don't know if this one will be first or this one, but one of them will win and the other won't. So if I do it again, this one won, okay? You can say 1 here and 2 there. In this case, this one will also win. Yeah. It consumes 1 and there is not enough token for this one. But if I say here I produce 3 tokens, there is enough for all. Okay? So you see here the philosophy of Petri Nets, which is a little bit different from the one from graph sets. But otherwise, you can do similar stuff, like, for example, adding some delay here, like for graph sets. You can also make it be a cycle. Three seconds. Okay. Exactly like for graph sets. Okay. So now let's see colored Petri nets. We forget this and we create colored Petri nets. That's similar, apart from the fact that the tokens have some colors. Here, instead of being just black, they are red. But they may have some different colors too. So we can make some combination. For example, let's say per default, I do this. And here I have 6 different colors. I say from step 1 I wait for 1 second. I have a red token here. I consume it and I will produce a blue one. Okay, red will be transformed in blue, and 1 second later, from step 2, the blue one will remain blue. So at the beginning it's red, and after 1 second it will be blue. Okay, and now as it is blue, it cannot go underneath anymore. So now we have to stop that, and I will add an alternative transition. I bind it. So now I say, if it's blue, I go on the right side and I produce a red one from step 1. Okay, so now let's see what happens. Okay, the red will be consumed here, a blue will be created, the blue remains here, and then as it is blue it will go on this side, be transformed in red, and here it remains red and comes back here and can go on the left side again and then on the right again. So that's a simple way to serve two different processes alternatively. Of course, you may make some more complex stuff. I have an example. So now I will just deactivate this left side and we'll concentrate on the right one. Let's run it and I'll let you discover what happens here. We have a kind of semaphore here, which is gathering the information that comes from the left and from the right. Okay, stop. If I now add 2 yellow token produced or consumed, I mean, we will wait until place 17 until 2 tokens are produced to go further and consume them. So that's one of the possibilities the colored Petri nets can offer. So you can play with that and see how far you go with that. Thanks for watching. Bye.